I decided to go over problem 4, but just give you hints because this is really a tying together problem, and I don't want to give away the ghost on something that is assessing your ability to put all the pieces of the class together. But I will give you hints because you guys really don't like word problems. But you're going to have to get used to it because the word problems are going to become more and more frequent. In service industries such as restaurant services, there can be recurring monthly costs: rent, franchise fees, and employee salaries. These are examples of those costs that stay constant. We call these fixed costs. Costs that can change by month to month depending on a quantity of goods sold is a variable cost. Now we are going to be looking at Crazy Uncle Jack's Cajun Catfish Shack for most of the semester. So now we're looking at considering opening another franchise of this. The franchise fee is $800 a month, the rent is $1,000 a month, and it's 85 cents for each hot dog. We have 35 cents for each hot dog roll, and one employee at $9 an hour for 300 hours a month. So we need to figure out what is the variable cost and what the fixed cost is. To figure this out, we need to ask ourselves what varies and what stays the same. Remember, we are doing this calculation for a given month, so would my monthly charges change or would they stay the same? So let's think about this. What is changing here? If we go back to this slide, we see that costs can change month to month depending on the quantity of goods sold. Quantity of goods sold. So here, in this, do I have a laser? I do. Here, we have a few things that change by goods sold, and we have things that stay the same month to month. Our 85 cents for each hot dog roll and our 35 cents for each hot dog and 35 cents for each hot dog roll depend on how many units we sell from each month. So that gives me a hint that maybe it varies or is a variable cost, whereas the rest are going to stay the same month to month. Now remember what our definition of fixed cost is, or just our cost function. Our definition of a cost function is our cost function, C of x, equals our variable cost times times our number of units plus our capital F, which is our fixed cost. So our little v, remember, equals our variable cost. And our big F equals our fixed cost. Okay, so remember to sort these out between fixed cost and variable cost. Now it asks us to perform a cost revenue profit analysis of this business opportunity. So you're asked to determine the selling price. So that means you pick it. Everyone asks this question: pick the selling price. If you want to make graphing, because I do ask you to do graphing, you want to try a site like Wolfram Alpha. So now we need to find our cost function. We need to find our revenue equation. And we need to find our profit equation. We define our cost by function by Vx plus big F. Our revenue equation is P times X. Now Px is our selling price. P equals our selling price. Now, the profit of X, we have a couple definitions, but they all mean the same thing. It's either our cost equation minus our revenue equation, or we can make it work easily for us and go our V minus P. No, it's P minus V, sorry. Okay, Control Z doesn't work. Where's my undo? Do I have an undo? No, but I have an eraser. So that becomes P, or our selling price, minus our variable cost, times our values, minus our fixed cost. So once we know our variable cost, our fixed cost, and our selling price, we can just go ahead and put it in this equation and work it out. When we find a break-even point, remember that the break-even point is where our cost equals our revenue, or where our profit function equals 0. So you can do either of these things to see what our break-even point is. Now, if I were to draw this out, now this is going to be a bad drawing, so I apologize in advance. I can't draw straight lines to save my life. I'm going to change some colors here. Our cost function is going to look something like this. Where it crosses the y-axis at our fixed cost. Our revenue equation is our revenue stream. That's going to start at 0 because there is no y-intercept. And it's going to go up like this. So this is revenue of x, where it starts at 0. But it meets at a point. That point is our break-even point right here. Okay? This x and y value, where these two lines cross, is our break-even point. And that break-even point is actually where our profit equation starts. That should be straight. Sorry. And yes, it is possible to have a profit equation go into the negative, because we can and will lose money on some investments. I would like to now move on to the last question. You are then asked to figure out what your profit would be for 4 different scenarios. So I give you 2,000 hot dogs a month, 4,000 hot dogs a month, 6,000 hot dogs a month, and 8,000 hot dogs a month. This is, you take your profit equation, and these are x values. Treat these as x values. So profit of 2,000 would equal whatever our profit equation was. So our price minus variable times our x, which is now 2,000. So whatever this came out to be, times 2,000 minus our f, whatever that was. Okay? And then you're going to do that for 4,000, 6,000, and 8,000. Then you're going to want to plot those on your graph as well. I'm going to include another video on how to use Wolfram Alpha. I hope this was at least helpful in the hint direction. Get back at me and let me know.